All right, everyone. Today, we're going to talk about the usefulness of heat maps. Okay, so heat maps are great for visualizing data in many different ways. We can look at, we can do interactive analysis. We can integrate heat maps with data frames seamlessly. I'll show you how to do that. Heat maps support all kinds of data storytelling. You can do customization and collaboration with stakeholders and teammates, real-time experimentation. It really helps to simplify somewhat complicated data sets. Heat maps support advanced analytics, reproducibility, and overall enlightenment, and helps you to make more informed, um, more educated decision making in your business, right? And overall enhances the way that data is presented and communicated to other people. So let's look at one simple example right here. I want to focus on the empty cards data set. So I've used this a lot in several of my videos. I like it. I think it's very poignant. It tells an interesting story. It's easy to utilize, easy to get, and it's kind of generic, right? So I try to make all my videos somewhat generic so we answer very specific questions, but I want it to be generic enough so you can utilize your own data in this scenario, right? Like your data is going to be different from empty cards. I can pretty much guarantee that. But I want you to be able to copy and paste that into these scripts I'm going to share with you and run that to answer your own questions based on your own data set, right? So here's the empty cards. We're going to pull this in from the web. This is stored under Seaborn, right? So Seaborn is the first plotting tool we're going to explore. We're going to look at a couple different plotting tools here. So Control Enter to run the cell. Okay, and we can see the head of the data frame here has miles per gallon. This is all automobile vehicle type of data, right? Miles per gallon, cylinders, displacement, horsepower, weight, acceleration, and so on and so forth, right? So here's the first heat map. So you can see the concentration is down here in the lower left, kind of like, I guess if this was a map of the United States, this would be sort of the southwest quadrant of this chart here. So we're looking at displacement on the x-axis and miles per gallon on the y-axis, and you can see the scatter plot is kind of all over the place, right? It goes up to the northeast. We don't really have southeast or northwest, but we have scatter around northeast, but the concentration is really the southwest, right? So most of the displacement and most of the miles per gallon is down here in the lower southwest quadrant, right? So this is called a hexbin plot, and hexbins are really good for showing you the density of data points in two-dimensional space. These are all two-dimensional. I actually ran one three-dimensional chart. It really looked kind of weird, and it didn't really add a lot of value. I feel like if you're making a chart, it should answer questions very easily. If you create a chart and it creates a lot of questions, that's probably not a good chart, right? Like a picture is worth 1,000 words. I always say that. So you rather than taking 1,000 words to describe something, if you could do that in one simple, straightforward, and streamlined image, that's way better than a complicated chart or taking 1,000 words to describe a scenario, right? You want to make these things as simplified as possible. So hexbins show the density of data points, and they're sorted into or arranged into hexagonal bins, right? So each color of the bin represents the density of that data point here. So you see the darker the color, the more dense, right? The count, we're looking at counts here, and the lighter the count, the less dense. So let's look at another example. I'll hit Control Enter here. So very similar to what we just saw with the hexbins, this is called Kernel Density Estimate, abbreviated KDE. And this is almost exactly what we saw before, but it's more of a smooth distribution of data points over a surface area, right? So rather than counting and binning all the data, we have like the actual distribution of data right here. So you can see the density again is the southwest part of the chart. You see some distribution up into the northeast a little bit, but most of it is really lower left area of the chart here. Again, we're looking at miles per gallon and displacement, just a different type of chart. This is the kernel density, doing almost the same thing as the hexbin plot, but just a slightly different presentation, right? So let me look at another data set here. Control Enter to refresh the data. So these are flights from 1949 going up to 1960. Okay, so let me refresh this again. Seaborne, we're using the Seaborne visualization tool here. So that's the abbreviation for Seaborne rates. So you see that right here. So as we pull this in, you can see the concentration again, lighter is higher and lower is darker. So in January of 1949, we had 112 flights that year. So this was nothing like today. Right? this is a far gone era. But back then they had 112 flights in January. And as we get up to 1960, you have many more flights. July and August, presumably these are like the vacation times when people are traveling for summer trips, right? So just a very clean, clear, crisp way to present your data with the concentration and the distribution of data. So the more concentrated it is, up to 600 flights, the lighter the color, and the darker the color, the less frequent the data points are, right? So there's different ways to create the visual effect here. You can have a figure size 12 and 6. Over here I'm using 9 and 6, all right? So 12 being the width and 6 being the length, and you can change the colors as well. So here's yellow, green, and blue. Over here we just had the default with no color setting. This is a default, and the annotation right here shows the numbers inside of the cell. So 100, 112, 115, 145 on the top. When you set annotation to true, you have that. I think it's a better effect than not. If I delete that, go back here, you still have the same color scheme, but just not as much data. I think this is just a richer, better overall presentation of the heat map. So here we just have different colors and different sizes in the heat map. Here again, I'm using greens. There's a bunch of different ways to do that. I put a link in here that shows you some of the different color schemes that you can pick from, right? Because this isn't completely intuitive. But if you go to this source over here, you'll see all the documentation of how you can pick different colors, how you can just render different images for your presentation, whatever you're trying to do. Okay, so that's pretty nice. Let's move on to Plotly. So Plotly is going to do very similar to what Seaborne does, but it's more interactive. So as you put your mouse over, it shows you a pop-up bubble here. The year's 1949, the month is January, and the color is 112. Actually, this is the counts of flights, right? So 112 over here, we have 622 and 606, which is exactly what we see over here, 622 and 606. Same thing here, right? It's just that these Seaborne charts are a little bit older. That's more of a mature technology. It's been around a little bit longer. These Plotly charts are a little bit newer, not quite as mature as Seaborne, but I like it a lot because it's more interactive. You can actually zoom in to different cells and see the detail of the cell, right? And then rerun the cell to get a refreshed image, right? If you want to see the holistic macro view, this will do that for you right there. And then again, if you show text auto equals true, then you get all the details inside of the cell, right? So you have all the annotations presented to you. If you leave that off, you have only the colors, right? So I think that is a very nice heat map. Let's look at this. Here's another Plotly heat map. So this is actually based, this is a time series heat map. So we're looking at, well, the one above is time series 2, but we're looking at like a different representation of data. So this is discrete. This is called discrete data, where you have different buckets of data, right? And everything is tightly wrapped into one bucket or another. This weather data right here, or temperatures, or this temperature data, changes constantly throughout the day, right? So it's called continuous. So this is non-discrete data. Over here on the top, these flight data patterns are discrete. They go into one bucket or another. This is continuous data where everything kind of overlaps. So you can see in January, based on the latitude and the time, the daily temperatures, with darker being more red, or warmer being more reddish, right? That makes sense. And colder is more blue. So very intuitive graph, and you can see everything plotted over time. This is just about 2 years worth of data from early 2013 to probably the end of 2014 right there. Yeah, December 31st. So it ends there, right? So you can see that's a pretty nice heat map, right? So let's look at another case here. Let me look at, take these out. I'm actually going to cut that. Okay, and run it. So this is a nice heat map of, what are we looking at? FIPS, which shows, is this running? Yes. Okay, so this shows distributions of population across the United States. Okay, most of the states there. And what's nice about this is you can add in more states. We have Colorado and Wyoming. Let me replace that. I'm going to go back there and rerun it. So this is pretty nice. It shows you populations by county. So FIPS data shows counties. It shows you the borders of different counties around the United States, right? And this, again, is a plotly map. So you can zoom in. You can see all the details here. This is Colorado and the FIPS data. So FIPS has not really a zip code. You'd have to look this up. Let me see. What is the FIPS data? Google it. I looked at this a while ago. I actually forgot FIPS data. FIPS. Ooh. State and county FIPS code. Okay. I think it's a little bit like a zip code. Yeah, and here's some FIPS codes. It's just a code for a county. So it's a little bit like a zip code, but it's for county codes. You could get zip codes. You could do this all sorts of different ways, right? So this is just what I found online. And this code is mine, by the way. I just found this online and just put this together, organized by types of heat maps, just to showcase the skill, the possibilities of what you can do in Python, and really the skill. To showcase the types of heat maps that you can create in Python. And you can see the darker code represents less dense population, and lighter represents higher density of population. So total population here, this is Los Angeles County, right? So that is pretty dense, 856K, 9 million here for LA County. This is 2 million. This might be San Bernardino County. I'm not sure what that is. 06071. Let me look at that. 06071. That doesn't actually show me. It's where 0607. No, it doesn't matter. I think it's San Bernardino County. Anyways, the point is, the lighter the color, the denser the population, and the darker the color, the less dense population, right? So again, it shows you concentrations, just like we saw in the hexbin and the KDE, continuous plotting of a heat map, right? So this is the same sort of concept. So let's go down here, refresh this view. So this is going to be, again, FIPS codes for the entire United States. Okay, and again, based on this is a slightly different metric. This is unemployment, U.S. unemployment rates. We're going to have different colors representing different concentrations of unemployment across the United States. So that's what we're looking at. Again, the heat map is a nice way to visually render what things are concentrated in what spaces. Easily, quickly, you can communicate the message pretty straightforward to your stakeholders, your audience, right? And the message should be pretty easy to interpret, right? And pretty straightforward. That's what we're going to see here. When the thing refreshes, let me see if we can find this 0607. When that's running, I'm going to try one more time. There it is. San Bernardino County. That's right. So I lived there for a little while, many years ago. For 20 years ago, 22 years ago, give or take. So that's actually the largest county in the United States. And you can tell from this map, the population is about 2 million people. Right? That's called the Inland Empire. So I think this is done nice. So we have now the unemployment, with darker being higher unemployment. So you can see some unemployment down here in Arizona, I think. New Mexico has some unemployment. Texas has a little bit over here. Coming closer to the East Coast, West Virginia has some unemployment, right? And this is kind of nice. If you click on these bars, you can actually interact with the map. So you can either erase it or add it in. All right, so pretty interactive, pretty nice way to utilize the features in this map. Okay, so there we go. Let me add this back. Okay, nice. So let me refresh this one here, and I will share all the code with you guys too, so you don't have to take notes, you don't have to memorize any of this stuff. I'm going to give it to you right when I post this video. In just a bit, I'll post all the source code, so you have everything. All you have to do is copy it, paste it, and run it in your Jupyter notebook. So now this is USA unemployment by county. Again, we're using FIPS data, similar to what you saw before. The only major difference here is that this map is not super interactive. Okay, you can't really zoom in. You can't really do a whole lot other than turn on and turn off these different unemployment metrics. But down here, I like this a lot because you can actually zoom in and you see the unemployment percentage. All right, so just like we saw before down here in Arizona, kind of high unemployment rate, 23%. And you have the FIPS code 06025. If I go there, what is that? That's what's going on over here. 06025. Imperial County. Okay, so Imperial County, lots of people out of work there. Not sure what that is, but okay, let's go to the East Coast. Zoom in. I live in New York City. Let's see, New York City, FIPS. Okay, so FIPS 4.5 unemployment. You see this on the news, on the local news all the time. Good Morning America reports on this. You see it in the local newspaper. So that makes sense to me. 4.5%. 25% seems a little bit high. I don't know what's going on in Arizona over there, but yeah, those guys should get to work. If you're able-bodied American, you should get back to work. 36061 is a FIPS code. Let me look for that. 36061. Your county right there. Okay, perfect. So that's just what we'd expect. Let me look at one more thing. Something caught my eye just when we were moving over to this map. Let me zoom out just a little bit. Okay, and Alaska. Oh yeah. You guys have to get your act together. Not as bad as Arizona, but Yukon 02290. Let me try that one. 02290. And that's Yukon Koyukuk. Okay, and that's just what we see here, Yukon Koyukuk. Okay, so there's definitely some unemployment going on. Hopefully those guys can resolve that. Okay, and there we go, San Bernardino. That's the largest county in the U.S. So this map I like. It's a little bit more interactive. It's way more interactive than the other one. Right, this one you had to kind of guess what was going on. This one, all the information is revealed, so it's very easy to work with. Very nice heat map. So let me refresh this one. So this is life expectancy over time. This is actually called a choropleth map. So it's another type of heat map. This shows you the counts or the density and the concentration of whatever your metric you're measuring. So here, when you mouse over, again, it's dynamic. The bubble pops up for you, so you can see the United States 68.4 is life expectancy. Over here in Africa, pretty low, 33 years. Here, 38.5. China, 44 years. But this is just the beginning, right? Going back to 1952. This is the beginning for this time series analysis. This is pretty nice because the map is not only interactive, but it's also a time series analysis. So it'll change when you click this play button right here, right? So if I put the mouse over here and hit the play button, you can see the United States starts off with 70. It goes up to 77 between 1952 and 2007. So presumably healthcare improved, probably technology improved as well. So people are living a little bit longer now, right? And then if we go over here, let's look at China. So median life expectancy 72 if we hit the play button, it starts off at 44 and it goes up to 72, not quite doubling, but that's a nice jump. These guys got a nice bump in life expectancy between 1952 and 2007. Let's look at one more choropleth heat map over here. This is world population. So the previous one was life expectancy, world population. Again, this is a time series, so we can hit the play button and we can see US 198 and went up to 301 by 2007. So 1952 to 2007, the population increase, and that totally makes sense, right? If you have life expectancy increasing, we just saw that above, life expectancy is increasing, total population is increasing, right? So we have more people living longer. That's what this shows. So let me look at, if I zoom out a little bit, let me go to China again. So China ends with 1.3 billion people by 2007. 1952 starts in 665 billion. So population actually doubled. And we saw in last chart that the life expectancy almost doubled too. So there we go. That's it. So those are heat maps. Those are the major types. I will share all this code with you guys. Again, heat maps are great for showing the intensity or the magnitude of data values as depicted through different color ranges, right? So different colors render different or represent different densities of whatever metric you're measuring, okay? So I think heat maps are really cool. They're very indispensable for making complex data sets more accessible, more actionable, engaging stakeholders, your end user, your end client, whoever you're working with. They really highlight the story behind the data and allow you to make more informed decisions, more intelligent decisions, and actually faster decisions too. So there you have it. I'll share all the code with you when I post this video later today. Thanks for your time and have a great day, everybody. Bye.